Det är igång den nu. Kändes det?
Det kändes bra, tack. Då blir det fotogivande.
Here we're going to learn something very useful that you'll use all the time. Remember that we have done for loops and if statements that contain only one statement to be executed in those cases, and that's useful for lots of things. But there are many times when you're going to want to execute multiple statements when you run through a for loop, for instance. So, as an example, let's create an integer, call it I, and let's create a for loop. And we can say I is equal to 1, I is less than or equal to 10, and we'll increment, so I equals I plus 1. Now, in case you missed it from a later section, we can, or a previous entry, we can do this like that, or we can just write I plus plus. That means I equals I plus 1. So in previous lessons, we might have done something like this, system.out.println. Right? We might have gone and done something like I is equal to, and we'll put a plus sign, and then we'll say I. So let's go and see what this looks like. I is equal to 1, 2, 3, 4, 5, all the way to 10, because as we loop through, I is being incremented, we're just printing this stuff out. Now this works great because there's only one thing I'm trying to do inside this loop, but what if I'm trying to do something else? Then the way you do that is you create a code block. Very easy to do. So you just put a opening bracket there, and then you're going to put a closing bracket around on the other side. So now everything for the for loop, everything inside of these brackets here is going to be executed with the for loop. Now the for loop is going to execute fine exactly as it did before because there's only one statement here, and I've enclosed it in brackets. It's fine. So I've got an opening and I've got a closing. What if I wanted to make this more complicated? What if I want to print something else out? Let's, for instance, say, let's create an integer called square, right? And let's say when I go through the loop, square is going to be equal to I times I. Right, so basically I'm squaring the loop variable, so as I fall through, 1 squared is going to be 1, 2 squared is going to be 4, and so on. As I get up to 10, 10 squared is going to be 100, 10 times 10. And what I want to do here is going to say I is equal to blank. Now let's go over here and let's add to this, comma, like this, and I squared is equal 2, and I'll come out here and I'll put a plus sign and I'll put square like this. Alright, now there is a semicolon at the end, and just to make it a little bit easier to read, after this plus I'll just go ahead and hit an enter here so that you can read the whole thing without going anywhere else. Alright, so make sure you understand what's going on. Inside of this for loop, I've got two things going on. I'm taking the loop variable, I'm squaring it, storing it into some other variable, and when I print it out, I'm going to get the square as well. So let's go ahead and say that. I is equal to 1, and I squared is equal to 1. I is equal to 2. I squared is equal to 4. So you can see as you go down here, 7 squared is 7 times 7 is 49. 10 squared is 100. This is the kind of thing that you wouldn't be able to do unless you created a code block. So code blocks are very useful for any kind of control structure like a for loop, also if statements, and the like. So later on we're going to get to while loops and all kinds of other looping constructs. Just remember, you can always put multiple statements here. I can do anything I want. If I want to do something here, I can say system.out.println, and I can say like this, I can say I love the moon, something like this, and then I can do a \n to give me a new line after I do that. So every time I loop through, I'm going to print I'm going to get an extra free line at the end. It's telling me I have an error here, and that's highlighted there. I just forgot a quick semicolon. That's very common. Go ahead and run it again, and let me go ahead and just scroll up, and you can see I is equal to 1 and I squared is equal to 1. I love the moon with a blank line, and so on. So that's just inserted in there, and you can see that you really do need a code block to pull this off. So this is a simple example, but there are many cases when you have multiple things to happen inside of a for loop, enclose them in blocks. Let me get rid of all of this stuff here, and let's go ahead and do something totally different. Let me clear this out. Let me show you how you might do this for an if statement, or a series of if statements. All right, let's declare the integer variable a, and let's declare it equal to 4. Right? Now let's go and create an if statement. If a is equal to 4, which in this case it is going to be equal to 4, so it's going to evaluate to true. Let me open a curly brace here. Now watch what happens when I press enter to come down. A new closing bracket is created for me by Eclipse. It's just trying to help me not to forget my closing braces there. So it's going to insert them for you a lot of times. So just kind of be aware of that. That's a nice feature. So if a is equal to 4, then what I'll say is a is equal to, actually let's do it like this. Let's say system.out.print. Actually, let's do it like this. Let's say a is equal to a plus 5, like this. So in this case, we'll say system.out.println, like that. And then we'll go and we'll say a was equal to 4. Now it is equal to space, and then I'll put a plus sign, a. So basically what's happening here is I'm going to jump through the loop, or I'm sorry, jump through the if statement. If a is equal to 4, then I'm going to add 5 to it, and I'm going to print this statement out here. A was equal to 4, now it's equal to 9 because I added this here. Now let me skip down under this if statement because this closing bracket defines the close of the if statement here. Let's do another if statement. If a was equal to 10, let me open a bracket. Let me come out here, and this lesson is going to be a double equal always when I'm doing ifs. Open a bracket, enter. I've got my closing curly brace already created. A is equal to a plus 10, let's say, and we'll go system.out.println like this, and I'll say a was equal to 10. Now it is equal to, and over here I'll print the value of a. So what do you think is going to happen when I run this guy? It still prints a was equal to 4, now it's equal to 9 because originally I had it equal to 4. This if statement was executed. This if statement was completely skipped because it wasn't true. But if I go up here and I change this to the variable, make the variable equal to 10, then this if statement will be skipped. So let's see if that happens. A was equal to 10, now it is equal to 20 because this guy was executed. What do you think is going to happen if I choose a value that's different than that? Let's choose 5. Go ahead and hit this guy. Nothing at all happens because this if statement is skipped and this if statement is skipped and the program terminates. So we'll go ahead and change it back to 4 just because we want to see some nice output. And that's basically all I want to show you in this lesson. The main thing is if you're doing an if statement that requires more than one statement inside the body of the if, then you need to enclose it with opening and closing curly braces. Same thing is true of for loops. Same thing is true of lots and lots of other constructs we'll talk about later. Just remember you can always group them like that. Every time you have an opening curly, you have to have a corresponding closing curly. Eclipse will try to warn you if you forget. It will also try to insert them in some cases. But if you get errors and you see little red dots on the margin here, then you need to go back and look at your closing curly braces and make sure you have them all in your code. Hello, welcome to Lesson 18 of Mastering Java. I'm Jason with CodeLearner.com. Here we're going to continue working with variable types or data types. We have learned in the previous several lessons, all the way up until we started first writing code, that the most common type of variable that we're going to use for whole numbers is going to be the integer type. And I believe I even told you that the range of the integer type in Java is this one here highlighted, a very large range of numbers from -2 billion, 147 million, blah, 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 up to +2 billion, blah, blah, blah. So for the great vast majority of cases, if you need to have a whole number in your program for whatever reason, just declare it as an integer because it's 32 bits, it's a huge range of numbers, and it is very likely going to suit your needs perfectly for almost every application. However, Java does provide other types of integers, and these are here, and I'll show you what they are. Well, another type of integer is called a byte, and you would guess that a byte consists of 8 bits, and so the range of that would be -128 to +127. So if, for instance, you were writing a program and you knew for a fact that the variable that you had and that you plan to use through all branches of your program would never get bigger than this range, then you could declare it as a byte, and it would only take 8 bits of memory. So if you were really programming for a situation where you were trying to minimize the amount of memory your program was taking, then it might be a good choice to choose a byte here. However, most modern computers have so much memory this is not a concern, but still, if you were programming for some embedded device or for some portable device, it might be useful. You also have the choice of declaring as a short variable. This one is 16 bits, and it is a range of -32,000 and some change up to +32,000 and some change. So this could be useful if, for instance, you're trying to save on memory and you know that your variable is going to fall between this range and so on. Now we've already talked about integers, which are 32 bits in Java, and they have this very large range. That's what you're mostly going to be using. And then of course we have something even bigger than the typical integer, which is 64 bits and has an enormous range. I can't even say this number out loud, it's so big. So it's just a huge number, negative all the way up to positive. So these would be used in times, longs would be used in times when you were doing calculations with very big numbers or very large negative numbers. Like, for instance, if you were calculating the distance between planets or something like that, where you were going to have a lot of digits that were falling outside of the range of a regular integer, then you might need to use a long. All right, so that is really all of the different integer types of variables in Java, but I want to stress before we get into a little example here, I want to stress a couple of things. The first thing I want to stress is 99.999% of the time you're going to just use an integer. So most of this lesson, I don't want to say that you can just discard it because it would be useful information for you, but most of the time, especially in the beginning, if you have use for a whole number in your code, just declare it as an integer. It's going to get you by with 99% of the cases. You only use these two if you're trying to save memory, and you only use this one if you have gargantuan numbers that you know you're going to be dealing with. Most of the time, just use an integer. Second thing I want to tell you is there are some gotchas with some of this stuff, and I'll show you what they are down here. So let's just kind of get right to the chase here. Let's say I wanted to declare a byte type of variable, so I just type the byte keyword. Notice that it changes to purple. And let's say I'm going to call it byte variable, like this. So, byte variable. So, byte, notice I'm starting my variable with a lowercase, and the next word I've capitalized, and this is typically how you want to name your variables in Java. All right, now let's initialize it, and let's start it off at a value of 100. So here, we know that this 100 is inside of the range allowable by a byte. So even though I'm not really doing anything, I'm not printing anything, it doesn't seem to give me any big errors, and when I run it, even though there's no output, it seems to have run okay. The only reason it didn't output anything is because I didn't put a print statement anywhere. But this seems to have worked. Now let's see what happens if I change this, and I change this to 135. This is outside the bounds of really what a byte is allowed to do. Notice that Eclipse has underlined it. Let me go ahead and save it. If I try to run it, it's going to throw up an error and say, hey, there's an error. Do you want to do this anyway? And you can try if you want, but it's basically not going to work right. If you hover over this, notice it says type mismatch, cannot convert from int to byte. Now, I want to explain what this means. In Java, whenever you type numbers in, forget about the left-hand side here. Here we've typed a number in, 135. Typically, when you type a number in, Java is going to sort of assume it's an integer unless you tell it otherwise. So this 135 is really an integer. And when you try to store it into a byte variable, it tries to convert that integer into the byte format, which is a fewer number of bits. All right? And the error is telling you it can't do that. It can't convert this number from an integer to a byte because it's too big, basically. It won't fit into the byte variable, so it's throwing up that warning. Back a minute ago when we had 100 here, Java was interpreting this as an integer, and then whenever it stores it in here, it converts it down to a byte. And since this number is small enough to fit inside of the byte, there are no errors and no warnings, and it all worked transparently. So I guess what I'm trying to say is if you try to put a very big number in here, negative or positive, that won't fit, if you get something underlined, even no matter what it says cannot convert int to byte, just note that what that means is it's basically too big. It's not going to work. All right, so let's go ahead and set this back into a range of something we know we can put in there. And let's move on to the next variable, short. If you wanted to declare a short variable, we can call it short variable like this. And I can set this equal to, 32,000 even. All right. Now this will fit fine because the range of a short variable is negative to positive 32,000 and some change, so this fits in there just fine. But again, whenever I type this number in, this is called a literal. Whenever I type a number into Java, like a constant or something, it's called a literal, and Java has to interpret it some sort of way, so it assumes it's an integer. When you type numbers in, whole numbers like this, it assumes it's an integer, and whenever it tries to store it into this short variable, it converts it to a short, and it basically chops away a lot of bits, putting it into a 16-bit format. And since this number is small enough to fit, everything works fine. But if I try to go up to 40,000, for instance, that's outside the range allowable, and so when you hover over it, it says cannot convert from int to short. It's a cryptic message if you don't know what it's saying. What it's saying is Java is trying to convert this integer that you've typed in into a short, and it's not working because it's just out of bounds. So that, again, if you see red squiggly underlines, that means you made a mistake. So let's put this as negative 2,000 or something that we know fits in range, and you see everything goes away. Now we've already talked about integer variables. We've already done that, and let's call this one int variable, and let's assign that one equal to 100,000. And this works fine because, again, on the right-hand side I've typed in a number, which is an integer. And since what's on the right-hand side is an integer, and what we're trying to store it into is an integer, there's no conversion that needs to be done, so everything's fine. But if you try to put something too big here, let's just start sticking a bunch of numbers in here, and click off of it, notice we've underlined it, and now it doesn't say that it has a problem converting. It says the literal, and it tells you what it is, of type int is out of range. It doesn't tell you there's a problem converting because it's not trying to convert anything. When you type this number in, it assumes it's an integer. You're trying to put it into an integer variable. The types match. It's just that this number is basically bigger than can fit inside of an integer. And so there's a problem there. So again, if you see red squiggly underlines under your numbers, that's a problem. So let's go ahead and take this out and put it into a form where there's no errors. And finally, let's go to our friend, the long variable, which is long variable, right? And let's put a number, 500,000 in there, right? And again, this is working fine because this is an integer, and then whenever we type numbers in here, it's an integer, and it's trying to convert it into a long variable, but which is fine. It's totally within the realm or the range of it, so it's all going to work fine. But let's see what happens when we add a bunch of digits. So here we have, notice in our numbers up here, we have 1, 2, 3, 4, 5, 6 set of threes. So here's 1, 2, 3, 4, 5. So it's 5 sets of 3. This number seems to be perfectly within the range of the long that we have here. But again, it says the literal of type int is out of range. And this makes no sense at first glance because, first of all, this is not an int variable. What is it saying? Again, when you type numbers into just code like this, it's called a literal. That's why when you hover over it, it refers to the literal, right? So this is automatically going to be assumed to be an integer. It's the same as it was up here. This was an integer that it's trying to store in a byte, and if it needs to convert, it will. This is an integer that it's trying to store in the short variable. It'll convert if it needs to. This is an integer over here. Of course, it's going into an integer variable. And this is an integer that's trying to be stored into a long variable, but it's giving us a problem. It's telling us it's out of range, and we know that it's not. The problem is not that it's out of bounds in this range. The problem is that this is an integer on the right-hand side, and the integer on the right-hand side, because we've typed a number, is outside of the range of what integers can be, which is this. So that's a long-winded way of saying that we need to tell Java that this number over here, stop trying to treat it as an integer, treat it as a long. And the way you do that is you put an L at the end of it, and notice everything disappears. So now it tells me that this variable here is now going to be treated as a long, not as an integer, as a long, and that's going to be stored into the long variable that we have defined right here. So now if we go to system.out.println like this, and then we just put the variable long variable, let's just print the variable by itself. We'll put a semicolon at the end. We'll hit save. Then what gets printed out here is exactly what we expect. If we take the L away like this, there's a problem, and then things are not going to be working right. Now, you can use a lowercase l or you can use an uppercase L. Basically, you can put an L next to a literal, which is a number that you type in, if you know and you're trying to tell Java to treat it as a long. So this is typically done whenever you're initializing long variables. It's something you see a lot. All right. Now let's go here, and let's under this guy, under this print statement here, let's say long variable equals long variable plus 1, like this. And then let's go to system.out.println like this, and let's do long variable like this. We'll go ahead and hit save. We'll print, and notice that we've added 1 to it, and then we've incremented, because in this calculation statement here, what we have done is we said, hey, this is a long. It's declared as a long. What's stored into it is a long. We're adding 1 to it. So if you really think about it, this number 1 is an integer. It's going to be treated as an integer in Java. This is a long, but whenever you have mixed types like this, Java's pretty smart. It knows, hey, this is a long variable. This is a little tiny integer here. We're going to add them up. We're going to treat the result as long, stored in this variable, so that everything works just fine. So this is kind of a long-winded explanation for a pretty simple concept. I just want to make sure you understand the different types of integers available to you in Java, but again, talking about some of the gotchas here. To summarize, 99.9% of the time, if you need a whole number, just use integer. All the default numbers you type in are going to be assumed to be integers. All of the adding and subtracting, multiplying, dividing are all going to be done in terms of integers, so just use integers. If you really have large numbers, declare them as long, but just be aware that when you store numbers into them, you need to tell Java to treat the numbers as long whenever you make the initialization, right? And if you have occasion or need to use smaller data types, which would only be done if you're trying to save memory, if you're programming for an embedded device or like a pocket calculator, wristwatch, something that doesn't have a lot of memory, then you can do that, but you just need to be aware of the size of the data types and keep track of all that stuff as you're doing your programming, because that's going to become critical for you. And we showed a few times when you're trying to make those assignments how sometimes you can get errors thrown up when you're not in range. But the takeaway is use integer whenever you can, because that is really the default integer type within Java, and it's the one that's going to be used most frequently and the one that you're going to be able to use in 99% of your programming. Hello, welcome to this lesson of Mastering Java, and what we're going to do here is talk about additional floating point data types. We've talked about the double quite extensively, and that's for a good reason. It's because the double floating point representation is really the standard, it's the default, it's the most common variable type you'll use for floating point numbers in Java. And what do we mean by floating point anyway? It just means anytime you have a number or a variable that's going to contain a number that has a decimal point. So for instance, 1.5 is a floating point number. 32.89 is a floating point number. Negative 0.62 is a floating point number. So integers are whole numbers. Floating point data points or data types are numbers that have a decimal point. Okay. Now here's the deal. The typical standard floating point representation in Java is 64 bits. So this 64 bits means you have a whole lot of decimal places after the decimal point where you can have numbers. So you basically can have longer numbers with more digits after the decimal point. But Java also provides what we call float. Float is a data type. It's a floating point number, but only has 32 bits. 10, 15 years ago, this would have been very standard for your floating point numbers to have 32-bit representation, but now computers are so powerful and we have so much memory that the standard is what we call double. So back in the day, your normal float would be 32 bits, and your extended float with more digits would be what we call double. Double meaning double precision. But it's now flipped around in Java where the typical standard is this one, and if you need a smaller number for some reason, or numbers that don't have that many digits behind the decimal point, you would use this one here. Again, I'll say again, just like with integers, 99.99% of the time you're just going to use double, just like we've been doing all along. But in this lesson, we'll introduce the other one just to show you. So as we said before, double is the standard default data type that we use in Java. So you can say double num1, and you can make it 74.33 if you want, and make that assignment. Most of the time, you'll be declaring double variables with the keyword double, which is what we've been doing in all the programs up to this point. Now, occasionally, if you're writing a program that's operating on an embedded device with less memory, then you might want to declare your floating point numbers like this and save a little bit of memory, because every single variable will have less bits assigned to it than if they were all doubles. So if for some reason you wanted to do that, you would declare a float with the float keyword. Notice that it turns purple as well. And I can say this is num2, and I can say this is 76.3 or 54, something like this. And notice what happens when this goes on. When I declare a float, and then I give it a variable name, and then I put what I think is a very common standard number that I might put here, it's underlined in red. When I hover over it, it says type mismatch, cannot convert from double to float. And this kind of stuff infuriates new people that are new to programming. We've also talked about it a lot in the last couple sections. We talked about different data types with integers. What's going on here is anytime you type a decimal number, this is called a literal, when we type the number in just like this. When we type this literal here, Java assumes it's double, because as I said, double is the standard floating point data type that we have. So it assumes it's double. And then whenever we take this and we put it into a floating point number, Java throws up a red flag here, because here's the deal. This double precision number is 64 bits wide. That's a whole lot of space for a lot of precision. And here we're trying to tell it to stuff that number into a floating point, which is only 32 bits. So if you really do want to store this number in 32 bits, then it's possible, especially if I had a very large number like this, it's possible if I tried to do this storing that I would truncate a lot of data, I would truncate a lot of decimal points, because I'm only storing it in 32 bits. So it's giving me that red flag, and it's telling me I can't convert from double to float. What it really is trying to say is I can't do this conversion without losing some digits behind your decimal point. So let me show you. If you really are going to use floating point numbers of type float, then what you do is very similar to the integers. You put an F at the end of it. And that tells Java, don't treat this as a double, treat it as a float. It tells Java, yes, I understand. I want to store this in this float, and I don't want you to treat this as a double, so there's no problems converting it. I just want you to store it in a 32-bit wide number. So effectively what's happening is this number is being treated as 32 bits, which is plenty big enough to hold these 4 digits in a decimal point, and we're putting it in the number there. So if I want to do system.out.print line, something like this, then I can print the number that we have here, which is num2, like this, and I can hit save, and I can run this. And notice what happens. 76.53 is what gets printed on the screen. Now let me show you something interesting. Let me go ahead and put a whole lot more digits in here. Let's say like this many digits. All right. I'm telling Java, here's the digit I have. Now we don't even need that many digits. Maybe like this many. Here's the number I have, 76.538987908, and so on like this. So this takes a lot of bits to represent all this information. But I'm telling it to treat it as a floating point number. Let's see what happens. Let's hit run. Notice what happens. Java only gives me back 76.53988. In other words, what was stored in this variable num2 was a 32-bit representation of this huge number. So because I forced it in there, I have to give up something, and I'm giving up digits behind the decimal point. That's what your limitation is. Basically, this is going to be how many digits you're going to be able to store in floating point numbers that are of type float. Doubles can hold a whole lot more digits there. So just kind of keep that in mind. The bottom line is if you're going to use floats, you need to put that F at the end to avoid any problems. And so, if you keep it small enough, like 76.5398, it's not a problem. But if you have very large numbers after the decimal, you're going to run into problems. So let me take this off from now, and let's go ahead and do a calculation. One of the reasons why double is the default floating point type in Java is because all of the math functions in the math class that you have available, they all take double numbers for inputs, arguments, and they return double precision numbers for answer. So for instance, let me show you something. Let's create another variable. We're going to call it answer, like this. Okay? And I'm going to say answer is equal to, and I want to use a mathematical function. Watch this. Math, I'm going to type it with a capital M, and I'm going to put a period. And when I put a period like that, then this dialog pops up, and it's telling me that of the math class, right, these are the available methods. And you can see tons of methods here. You have absolute value, inverse cosine, you have cosine down here, and you start scrolling down this list. You have sine, tangents down here, convert from degrees to radians. I'll do more videos in the future about showing you how to use a lot of these things. Here's absolute value. So as I look through this class here, this math class, I'm going down to the S, and I see SQRT. That's the square root of a number that's double A. So that means the argument needs to be a double, and it's going to return a double. So I'm going to click that, or I could just type it if I want. I could double click, and it's telling me here's the square root, and I'm going to type in whatever my number is right here. And so for me, let me type in num1 because that's the variable I've already assigned. I'll put a semicolon at the end there. So notice the way this is written. It looks just like system.out.println, right? So you have a general class. In this case, it's the math class. The dot comes, and then this is a method that is a member of the math class, right? And so these are all done for you, and you don't have to really reinvent the wheel all the time. You're taking the square root of this number. The answer is going to give you a double precision floating point answer, and I'm going to store it in this variable, which I've already created, called answer. And so if I wanted to print the answer out, like this, then I could say let me do it like this, the square root of, and I could put num1 is answer, like this. All right, so let's go ahead and hit this guy, see if we ran into any errors along the way. The square root of 74.33 is 8.62, blah, blah, blah. Look at all the nice precision that I have after the decimal point because it's taking arguments in and it's returning an argument. You know, we're going to get in a lot more later into methods and creating your own methods, but here's a great example of a method that you're calling from within the Java standard class libraries. The math class contains a method called square root. They've already done the heavy work for you so that it's doing the square root, and what it's returning is it's returning a number, which is also a double that's being stored into answer, and then that's what I'm printing on the screen. So when you have a minute, you might want to go type math dot and then start looking at a lot of these things and just kind of become comfortable. I'll do a lesson in the future to show you some of these things, but there are lots of things that you might have use for right here inside of the standard math library from within Java. So now that you understand a little bit about the difference between doubles and the difference between floats, the one thing I want you to take away from this lesson is that 99.9% of the time you're going to declare everything with a decimal point as a double, and the standard functions are going to work fine with that. All right. If you have to declare something as a float because you're trying to save on memory, then you need to put that F at the end to tell it to treat it as a floating point declaration and a floating point initialization of that variable. So go off to the example there and try to take a look at that. You get to use another function of the math library from within that example. So go read that example, do that yourself, and then take a look at my solution. And as we work forward, you'll build your skills step by step. Next, press any second key. So this is the prompt for the user to go ahead and press another key. So what do you think we should do? Well, we've already stored the first input into this variable and we've put it to the screen, so we can just collect the second input, right? So actually it's an exact copy of this statement here, so we can just copy this guy, just copy, you can drop it down there and paste it. It's the same thing as typing it in again. Essentially we're collecting another system.in.read, casting it as a character, and then we want to go ahead and print that out to the screen. So we can save a little time by copying this guy, which is just basically putting to the screen exactly what we input there. So let me pull this up here. And let's do this. Your second key was... All right, so study this for a second and make sure that you agree that you think it's going to work. Basically, we're going to enter a key, collect it, put it to the screen, and then we have another message, enter a second key, and actually I'm going to skip a line down, \n to push it down. Then we're going to collect that second input and we're going to put it to the screen. Let's see what happens. Let's go ahead and save it. Let's go ahead and run it. Press any key, then enter. So I'm going to put a Y, and I'm going to hit enter and watch carefully what happens after I press enter. So what it says is you entered the key Y, then immediately it says press any second key, and it doesn't even really wait. It says your second key was, and it's basically blank. This is not how we expected the program to flow, because we think that when we get to this step, system.in.read, the system will stop and wait for keyboard input, then we print it to the screen, then we say, hey, press a second key, then we expect this to pause the input again and say, wait for another keyboard, and then another keyboard entry, and then we'll put it out to the screen. But that isn't what happens. As soon as we get to this guy, it seems to print these to the screen without really waiting for our second user input. This is the kind of stuff I'm talking about when you have a gotcha here. It's something that you need to know how the thing actually works. The bottom line is the system.in.read command or input method. It basically reads 1 byte from the keyboard, right? But the thing is, or 1 character from the keyboard. But the thing is that it's the method is what we call line buffered. And what that means is that basically when you type the Y, let me run it again. Notice nothing happens. You can put the letter U. Nothing happens until I actually press enter. When I press enter, then it sends whatever I typed into the keyboard into my program, and then it continues on. But it only actually sends it to the program whenever I press enter. And also, this system.in.read, it only reads 1 character, also known as a byte, 1 byte at a time. So when we enter the U and we press the enter key, then this read command reads the letter U, then we print it to the screen. But here's the real gotcha here. If you remember, this table right here, this is the ASCII character table. So for instance, if we enter the letter lowercase u like we just did, then it corresponds to a value of 117. But what you need to know about keyboard input is when it's line buffered like that, what that means is you type a bunch of stuff into the keyboard, it goes into a temporary memory area, and then when you hit the enter key, everything gets passed to your program. All right? But look over here on the left-hand side. See, we have all of these keyboard symbols here, but on the left-hand side, we have all of these like invisible things like tab, line feed, form feed, carriage return. There's a lot of other things here, and they all have corresponding ASCII codes. So whenever you actually hit enter, whenever you type the letter U and hit enter, what you really are sending your program is the letter U, but because it's line buffered, at the end of the line you always get a carriage return, right? And you also get a line feed. The carriage return is when the cursor goes back to the beginning of the line. Like if this were my line here and I get a carriage return, that sends it to the beginning of the line. And you also get a line feed that pushes the text up a little bit like this. So you got to think back to the old days here. Like this is some of the exercises we're going to be doing here in a minute over here. I've got them in Notepad, but basically you can think of, let me go and scroll it off the screen. If I enter the letter U and then hit enter, notice how when I hit enter, the cursor goes back to the beginning of the line and it skips down a line. So going back to the beginning of the line is the carriage return. The line feed is pushing the cursor down to the next line. So the bottom line is, whenever you hit the letter U and press enter, you're getting the letter U, which corresponds to 117, sent to the program, but you're also getting this invisible carriage return, which is decimal or integer 13. You're also getting a line feed, which is another character, which is invisible. So they're non-printable, but they're in the input stream, right? So then the bottom line is when you get down to your second part here, the second system.in.read, it goes into that little buffer area of memory to see what's in the keyboard buffer, and it sees that there's still a carriage return and there's still a line feed in there. So it doesn't wait for another enter. It sees that there's something already in memory waiting to be read, and it reads it in. So it reads this invisible carriage return, and then it prints an invisible carriage return right here. So that is why Java the default way of doing this here, the easiest way to do this here with system.in.read is very nice if you're just reading one character, but it's got some gotchas because if you try to do two sequential reads, basically these invisible characters at the end of the keyboard buffer cause problems. So the way you get around it, that's really all we care about, is after we read the first letter here, this one right here, we need to do a couple of more reads. So let me go ahead and copy this. I'm going to do Control-C, copy. I'm going to do a paste here, and I'm going to do a paste here. What we're doing here by inserting these guys is we're reading those two invisible items, the carriage return and the line feed, and we are basically reading them and discarding them. So what's going to happen here is we're going to read the first character, we're going to print it to the screen, the carriage return and the line feed is still in the input buffer. We're going to read the first one, discard it because we're not doing anything with it. We're going to read the second, discard it because we're not doing anything with it. Now the buffer is empty so that when we get to our next read, it's actually going to pause and wait for us to type something. So let's go ahead and save this and hit enter. So our first guy is a U. Now we'll hit enter and notice that it says you type the key U and it's waiting for another input. That's because these two reads right here emptied out our buffer of the carriage return and the line feed, those invisible characters there, and now because it's empty, then when we get to this read down here, it waits for us. So let's go ahead and type a J, and then it says your second key was J. That's really what you need to know about using system.in.read. If you're going to read single characters in like this, then you need to, after each read, then you need to kind of do two dummy reads like this to get it primed and ready for the next one like that. Now notice after this read right here, there's still another carriage return and a line feed from my second entry, but I don't do anything with it because I don't care. My program's done. If I were going to do another keyboard input, I'd have to paste two more of these guys to kind of clear the buffer and so on. And, you know, along these lines, you can do some other interesting things as well. So this works fine if I'm going to do single character input. But what if I accidentally type in two characters? What if it's an accident? What if I type instead of a R, I put R and a T? So here I've put two characters in the buffer, plus when I hit enter, I'm going to get a carriage return and a line feed. Then what's going to happen is, again, it's not going to wait for me because this read reads the R in. This dummy read is going to read the T in. This dummy read is going to read the carriage return, which is invisible. And then when we get to this one, it's just going to read the line feed, which is invisible at the end as well. So if I accidentally enter more than one guy there, if I have two characters there, then I can just insert a third dummy read, and everything should be okay. So if I do T then U, then the program should behave properly. Notice that it tells me that I entered a T because it's only reading the first guy there, the first byte, and if I have an E, let's say, then my second character was E. So, you know, a lot of this stuff in Java is stuff that you're going to use here in the beginning. You know, we're doing these early programs. You're not going to use them a lot when we get to more complicated programs because there are more powerful and more robust ways to read keyboard input in Java, and we're going to get to those very soon. But I just wanted to make sure you understand this gotcha because it's very common for you to take a keyboard entry, a single character, do something with it, and then try to read a second input from the user. And if you don't know to do two dummy reads right here to get rid of the invisible carriage return and line feed, then you're just going to be beating your head against the wall for no reason, and that's because of the way it handles it. It's line buffered. When you press enter, you get a carriage return and line feed that are waiting there. If you don't read them and discard them, then when you get down to your next read, Java's going to be reading those guys in there. One more thing I'm going to do here before I close is I want to, you know, I don't want to kind of flog, you know, this into the ground, but I think it's really interesting that you understand how all this works. So what I want to do is, notice we're reading our first input, and then we're reading the carriage return and the line feed and throwing them away, and then we're reading our second input. Let's go ahead and print out the ASCII codes for these invisible characters just to convince yourself that that's actually what's happening. So what I'm going to do to show you how to do that is I'm going to declare an integer called input2. Input2. And what I'm going to do here is I'm going to read these dummy characters into the variable input2, but because I'm reading them in as integers, I don't need to cast them as characters. So essentially what's going on is I'm reading the first character that you input as a character and printing it out, and then I'm reading the two dummy characters, carriage return and line feed. But since I've declared this as an integer, remember I said system.in.read always reads everything in as an integer, so I'm going to put that into a variable, and I want to print the ASCII code out. And if I've done everything right, then I should see some of these codes over here that would correspond to what I've been telling you here. So after the first read, let's do system.out.println, and let's do invisible character like this, and we'll do input 2. And then I'm going to copy this. I'm going to hit Command C or Control C, and then after the second one I'm going to print the same thing back. So when we read our first dummy, we should see the code that corresponds, the ASCII code that corresponds to it. We read the second dummy in, we should see the invisible code that corresponds to that, and then of course we'll get to our guy there. So let's go and take our first input as an R. You entered the key R. The first invisible character that's read by the first dummy is 13. The second one is 10. So let's go over here and see. Look, 13 is the carriage return. 10 is the line feed. So that's proving to you that after the user input those two characters, the integer 13, which corresponds to this, and the integer 10, which corresponds to this, those are in the input stream. That's what I'm reading here and tossing away. In this case, I'm putting them to the screen so you can see them. And then I can enter, since I've emptied the buffer, it's waiting now for an input on this third read down here, or I should say this last read down there, and then the program continues. Your second key was I. I just wanted to put that in there to kind of prove to you what's going on here. So make sure you understand this. Go do the exercises. It's something that's interesting to know. Even if you never use system.in.read in a real program, it's important for you to understand how the keyboard buffer works. These invisible ASCII characters and things are things that you're going to benefit from going down the road, just learning how computers work, really. And that's kind of one of the reasons why I'm diving in so deeply into this area. Hello, welcome to Mastering Java. Here in this lesson number 3, we're going to really learn about a lot of things here. So I'm going to warn you up front that you might have to watch this lesson a couple of times to really understand everything that we're talking about. Nothing in here is hard, but I'm going to introduce a lot of new concepts that kind of need to be discussed in order for you to really understand what I'm talking about. So let's revisit what we've done recently. We've learned how to read a single character from the keyboard using system.in.read. And we were able to use that in many different ways, and it's really great. But the problem with that is it's really only intended to read 1 byte at a time from the keyboard, which is 1 character at a time. So it's great if you're trying to answer yes or no questions, but what if you're trying to read a number, like a big number, like 347? I mean, you can see the number 347 is, or 345, let's say, is 3 characters. So I would have to do a system.in.read for the 3, and then another system.in.read for the 4, and then another one for the 5, and then I'd have to put all those things together and form it into an actual number to represent the number 345. So reading single characters from the keyboard to represent numbers is not really easy to do. Also, what if you wanted to do 345.25? How do you represent the decimal? I know you can read the period in from the keyboard, but how do you represent it as the number 345.25 when you're reading each character at a time from the keyboard? So, it's possible to do by reading 1 character at a time, but it's very cumbersome. So what I want to do is show you how to read integers in from the keyboard. If you want to read the number 1004, you'd be able to do that. And I also want to show you how to read characters from the keyboard or numbers from the keyboard that are doubles, which are decimals. So 65.325. The reason I want to teach you how to read things in from the keyboard early on in this course is because it makes programming much more fun. If I can write a program that reads in your age and then tells you something about it or calculates something, that's a lot more fun than just having these programs where I'm declaring variables and doing things with them. So what you're seeing in this lesson here typically is not taught until much later in a Java programming book. I want you to know how to read keyboard input because I think it makes the course more rich and more fun as you learn programming. All right, so having said that, I need to tell you that system.in.read, which we've done before, is only used really to read 1 character at a time. Lots of limitations. So how do we read integers, which are numbers, and how do we read decimals, double precision numbers, as we've discussed before? To do that, we're going to use something called the scanner class. Now, I know that a lot of you probably have heard of the term class before in terms of object-oriented programming language. We haven't discussed what a class is really much at all. We've done a little bit of discussion, but not very much. And we certainly are not going to discuss real object-oriented stuff until later in the course. But the scanner method that we're going to use here, the scanner class that we're going to use here to read stuff from the keyboard, it is a class. So I have to show you at least a little bit of object-oriented stuff so that you'll understand and have at least some idea of what we're talking about. So in order to actually use the scanner class to read from the keyboard, before your class definition here, you need to type in import java.util.S. You see it's trying to tell me here scanner, so I'll do scanner. And then you just put a semicolon at the end. All of the red disappears. Notice we have a little bit of a squiggly. If you highlight over it or hover over it, it says the import of Java util scanner is never used. Basically, in Java 5, which was quite some time ago, they provided the Java class called scanner. And that consists of lots of different methods and utilities used to read keyboard input that are much, much easier to use than system.in.read, reading one byte at a time. Much easier to use. It's very powerful. All right? But because Java's object-oriented, the scanner class is got some overhead to it I need to explain for you to understand. So the first thing we need to talk about before you do much of anything else is just do a little bit of a quick review of what a class is, okay? In Java or C++ or any of these three, we're going to really learn about a lot of things here. So I'm going to warn you up front that you might have to watch this lesson a couple of times to really understand everything that we're talking about. Nothing in here is hard, but I'm going to introduce a lot of new concepts that kind of need to be discussed in order for you to really understand what I'm talking about. So let's revisit what we've done recently. We've learned how to read a single character from the keyboard using system.in.read. And we were able to use that in many different ways, and it's really great. But the problem with that is it's really only intended to read one byte at a time from the keyboard, which is one character at a time. So it's great if you're trying to answer yes or no questions, but what if you're trying to read a number, like a big number, like 347? I mean, you can see the number 347 is, or 345, let's say, is 3 characters. So I would have to do a system.in.read for the 3, and then another system.in.read for the 4, and then another one for the 5, and then I'd have to put all those things together and form it into an actual number to represent the number 345. So reading single characters from the keyboard to represent numbers is not really easy to do. Also, what if you wanted to do 345.25? How do you represent the decimal? I know you can read the period in from the keyboard, but how do you represent it as the number 345.25 when you're reading each character at a time from the keyboard? So, you know, it's possible to do by reading one character at a time, but it's very cumbersome. So what I want to do is show you how to read integers in from the keyboard. You know, if you want to read the number 1004, you'd be able to do that. And I also want to show you how to read characters from the keyboard or numbers from the keyboard that are doubles, which are decimals. So 65.325. The reason I want to teach you how to read things in from the keyboard early on in this course is because it makes programming much more fun. If I can write a program that reads in your age and then tells you something about it or calculates something, that's a lot more fun than just having these programs where I'm declaring variables and doing things with them. So what you're seeing in this lesson here typically is not taught until much later in a Java programming book. I want you to know how to read keyboard input because I think it makes the course more rich and more fun as you learn programming. All right, so having said that, I need to tell you that system.in.read, which we've done before, is only used really to read one character at a time. Lots of limitations. So how do we read integers, which are numbers, and how do we read decimals, double precision numbers, as we've discussed before? To do that, we're going to use something called the scanner class. Now, I know that a lot of you probably have heard of the term class before in terms of object-oriented programming language. We haven't discussed what a class is really much at all. We've done a little bit of discussion, but not very much. And we certainly are not going to discuss real object-oriented stuff until later in the course. But the scanner method that we're going to use here, the scanner class that we're going to use here to read stuff from the keyboard, it is a class. So I have to show you at least a little bit of object-oriented stuff so that you'll understand and have at least some idea of what we're talking about. So in order to actually use the scanner class to read from the keyboard, before your class definition here, you need to type in import java.util.S. You see it's trying to tell me here scanner, so I'll do scanner. And then you just put a semicolon at the end. All of the red disappears. Notice we have a little bit of a squiggly. If you highlight over it or hover over it, it says the import of Java util scanner is never used. Basically, in Java 5, which was quite some time ago, they provided the Java class called scanner. And that consists of lots of different methods and utilities used to read keyboard input that are much easier to use than system.in.read, reading 1 byte at a time. Much easier to use. It's very powerful. All right, but because Java's object-oriented, the scanner class is got some overhead to it I need to explain for you to understand. So the first thing we need to talk about before you do much of anything else is just do a little bit of a quick review of what a class is, okay? In Java or C++ or any of these other object-oriented programming languages, you need to understand what the concept of a class is. A class is a template. Say that to yourself. A class is a template. A class is a template. If I were going to make a template for a car, right, then I might want to specify that a car might have wheels, it might have tires, it might have a radio. So I might want to define a bunch of features that I think a car has. A car might have a top speed, etc. So if I were going to define a class called car, I might provision in there to define what the wheels might look like, what the tires might look like, what type of radio it has, what kind of top speed it has, and so on. But I'm not really defining a specific car. I'm defining a class called car, because all cars have wheels, and all cars have tires, and all cars have radios, well, almost all of them, and all cars have some kind of top speed that I can define. So instead of, when I'm writing my program, defining every single car over and over and over again, I might just define this template called car that has all these attributes that are common to all cars. Now then, if I want to actually use one of these cars in my program, maybe I'm writing a racing game or something and I've got 10 different cars, so I've got the template defined, so then I might want to create an actual instance of one of these cars. So what we say is we create one of these objects called of the car class. So that's what you hear, object-oriented programming. It's all about creating an object from a class, which is a template that you've defined. So instead of just defining car, right, I might then in that case define Honda, right? That's, you know, a very specific type. Or maybe I wanted to say it's a Honda Accord. That's a very specific type of car, but we know the size of the wheels and we know the top speed and we know everything about the Honda Accord. So then I can make a copy of the car class, which contains all of the attributes, and I just assign values to them or whatever I'm trying to do to define the details of the Honda Accord. Maybe I have a Honda Civic. Maybe I have, you know, a Honda, well, let's do Toyota minivan, right? So you see, they're all, even though this is a minivan, they're all sharing attributes with the general thing that we call a car class. We know that they have top speed, we know they have tires, we know they have all these things. So we can then define an instance of one of these cars, and we'll call it a Honda Accord. We can define an instance of one of these cars. We'll call it a Honda Civic. We can define an instance of one of these things. We'll call it a Toyota minivan. So another way of saying it, instead of calling it an instance, you can say you're creating an object. We're calling it a Toyota minivan. We create an object called Honda Civic. This is all terminology. And so you're basically creating objects from the class, which is a template that's already been created for you, or when you get more proficient in programming, you can create your own classes. So let me put that aside for a second and tell you that the creators of Java have created a very powerful class called the scanner class. This line at the top of the program just imports that into our file here so that we can use that scanner class. All right, so the first thing we want to do is create an instance of that scanner class so we can use it to read from the keyboard. Another way of saying that is we want to create an object from the scanner class so that we can then use it. And the way you do that in Java in terms of creating a scanner class, let me just type it all out and we'll talk about it. You type scanner, right, and you have to give it a name, just like when you're doing an integer, you have to give the integer a name, right? So in scanner, we'll just call it keyboard input. Notice I have the K lowercase and the next word uppercase. That's pretty typical in Java. So this is kind of creating, if I just left a semicolon there, that would be kind of creating the basic idea of what we're trying to do of creating an object. But what we want to do is we want to create a new scanner object. Oops. And we'll put a semicolon there. And on the inside of the parentheses, what we need is system.in. All right, I'm done typing. All the red text goes away. This thing right here, every single time you use a scanner in order to read stuff from the keyboard, you need to have this line in the beginning of your main method. You'll also need this line up here. All right, so what it's doing is this is not just something that scanner uses. This is the way that you declare, and I should say that you create objects from classes in Java. So what you have is, this is the scanner class. This is the name of the object that you are creating. So this is the general class. This, in our previous example, would be Honda Accord. We would be calling it Honda Accord, or we'd be calling Honda Civic. Here we're calling it keyboard input because it's a specific object of what I'm creating that I'm going to use. So I'm creating that thing, but I've got to assign something to it. So I'm creating a new scanner object, right? And this scanner object is reading stuff in from the default system.in, which is the keyboard. Some of this stuff can get a little confusing on the right-hand side because we haven't talked about constructors and other things in object-oriented programming language. But basically, whenever you create an object, the thing comes into existence with a constructor. So what happens is we're creating a new scanner object, and we're telling the system to read stuff in from the default system.in. You know how we did system.out before when we do something like system.out.println? Well, the system.out is telling Java we're printing to the screen, right? System.in is telling it that it's coming in from the keyboard. It's the default input method. So just kind of get used to seeing this. This, you can kind of think of it, you know, how we do things like integer, age, and length. Maybe we create some variables called age and length. Well, this is the type of variable, and this is the name. You can kind of think of this as the type of object, or in this case it's the class, and this is its name, and then so we create that and we have to set it equal to something, but in this case we're creating the new object, so the new keyword creates the new object of scanner type, and everything's coming from the keyboard. Alright, I know that could be a little bit confusing. You need to get kind of used to seeing that because we're going to use it here every time we read from the keyboard. We're also going to use it later on when we do real object-oriented programming, which we haven't gotten to yet. I could just tell you, hey, type this in, but I'm trying to tell you what it is so that you understand it. Okay, so this creates our object called keyboard input to read stuff from the input from the keyboard using the scanner class that's provided in this guy up here. All right, so now we want to finally do something. So let's go ahead and put something to the screen, system.out.println. So let's read an integer in. That's the easiest thing to do. Enter any integer like this. So we'll do an integer there, and what we want to do, let's create an integer called test. We'll just call it test. So we've created an integer called test. We print something out to the screen, says enter any integer. Now we have to ask for the keyboard input to actually come in. So what we're going to do is we're going to use the scanner object that we've created called keyboard input to do that. Now, we've talked about the class. We've talked about creating a new instance of that class. This is the name of it. All right. Now, the other thing you need to realize when you create objects like this is they're going to have methods associated with them. When you create a class, you define methods that make sense for the class. In this case, we need some methods to read stuff from the keyboard. So the main method that we're going to use here is keyboard dot, or I should say input. This is the scanner object we've created, dot, and then we will say next int, like that. When you type this in, keyboard input, this is the scanner object that we have. The dot says we're using a method from that class. Next int is one of the methods of the scanner class. So when we've created this object here, then the next int method is automatically available to be used. So this means next int means we're reading the next integer. So what we want to do finally is say test, which is our variable, is equal to that. So make sure you understand what's happening here. We print out enter any integer. right? And then we're saying that our variable up here, which is an integer, is equal to reading in from the keyboard the next available integer that's there. All right. So then let's go skip down here and say system.out.println, and we'll say you entered the number, and we'll do it like this with a plus test. Because we've already read it in, we've already stored the value in the variable called test. Now we're just printing it out to the screen. So let's see what happens. We'll print this guy here. Enter any integer. So we'll enter the integer of 5, and we'll hit enter. You entered the number 5. The program is over now. Notice how control is back. It's blinking, but there's not really waiting for anything. We can do it again. 925. You entered the number 925. Integers are positive or negative quantities, so we can say negative 98. You entered the number negative 98. So every time we run through the program, we basically are going to be reading in from the keyboard with this line here, the integer that's available to be read, and then we're going to be storing that into the variable called test. And then we can use this variable anywhere through our program, just as we've done any other variable or any other integer that we have. So from this point on, I can use test in for loops, in if statements. I can use them to calculate things. For instance, I could come down here and say, let's do another one here. Let's create a new integer called number. So number is equal to test times 10. Let's change this to number. So what we're doing now is we're reading in and we're multiplying the number times 10. We're storing it into a new variable and we're printing out the new variable. So now when I enter 45, I should multiply by 10 and I should have the number 450. All right. So notice that in this case, when I read the keyboard input, I'm reading next integer. I'm reading the next integer available at the keyboard. And I can go and read something else again. So let me go ahead and change this here. Let me take this out, and let me change this back to the number test, and let me take this out because I certainly don't need that anymore. So basically we're back to where we started. Right now, after I read this in, I can go and say, in fact, I can just copy this whole thing. I can hit Control-C for copy, and I come down here and paste it in. So I can say enter another integer. Let me go ahead and skip a line down here, \n, right? And then I can, again, read the next integer from the keyboard, store it into the variable, and then I could say you entered the number test. So let me go and hit this guy, enter an integer 5. When I print it out, it says you entered the number 5, enter another integer. It's waiting for input again. I can hit the number 8, you entered the number 8. Now the program is done. When I try to hit the keyboard, there's nothing else going on anymore. But notice that in each of these cases, I'm using the method called nextInt because I'm expecting to read an integer in there. All right, I'm expecting to read an integer in there. Let me show you what happens. Let me take off the second read here. Just delete that. Let me show you what happens if you put something in that's not an integer. All right, so let me run that. It's waiting for an integer, 4.5, right? So it's waiting for an integer. It's reading in with the nextInt method here, but I haven't actually input an integer. I put a floating point number in there. So I hit the enter key. Notice what happens. There's a bunch of exceptions. You've got an exception in this thread. You've got some stuff with Java util scanner. There's a throw here, a bunch of really weird stuff, but you know that there's a big error. In fact, it says input mismatch exception. That's a big clue for you. Anytime you see an exception, it's telling you error. There's an error of some kind. And what happened is I lied in it. Basically, I'm using the method to read an integer, but I actually didn't give it an integer. That's a big problem. I'm going to show you how to fix that in a minute to catch that sort of error, but I wanted just to show you real quickly what it does. So that kind of begs the question, then how do we read decimals? How do we read double numbers, which are floating point numbers with a decimal point? Well, let me show you how we do that. All right. So let's change this. So we'll do, this is an integer number. Let me just do this. We'll change this, change the variable names, integer number, and then this guy will be integer number. So everything is basically exactly the same. I can enter 8 and I get 8 back. Okay? I'm just changing it because now I want to create a double called double number, which is a decimal number. Okay? And I want to show you how to read that in. So let me skip down a little bit here and show you how to do that. So then what we're going to do is do system.out.println like this. and then I'll have a quotation in the center. Let me skip down 2 lines, and I'll say enter any decimal number. Double. Like that. All right? And then I need to read the keyboard input. So then I'm going to say, I'm going to store it into the variable called double number equals. I'm going to do the same thing again. I have a scanner object that we've called keyboard input. That's what I'm using to read all my keyboards. So I'm going to say keyboard input, but I don't want to read an integer. I want to read the next double. So that is a method in the scanner class. To read doubles, you use the method next double, and to read integers, you use the method next integer like that. So I've read it in there, and then I want to do system.out.println like this. You entered the double number, or I should say decimal just to make it clear. Decimal number, blah, blah, blah. And then over here, you just put double number, because that's the number I'm storing in. So let's just see if that works. We'll hit this guy, enter any integer. So we'll hit 7. I entered the number 7. Enter any decimal number. So we'll do 4.5. Notice this time you entered the decimal number 4.5. All right. So the bottom line is, when you know that you're reading integers, you need to use the scanner that you have created, dot next int with the 2 parentheses. This is a method, which is like a little subroutine that it's calling, and it's reading the next integer in from the keyboard there, and then you can use it as needed. In this case, we're storing it into a variable, and then we use it as appropriate. Then when the next text says enter your double, we're not using next int. That's for reading integers. We're using the method called next double, which is also a method of the scanner class that's available to read decimals. So that's the most common times you're going to read keyboard inputs. When you're reading integers, I'm going to recommend that you use the scanner class, create your scanner instance there, and then read integers in like this, read doubles in like this. Now let me show you one more thing. Actually, let me put that back, undo typing. Let me show you one more thing that's pretty important, that's very useful. Okay, we said before, we can run this again. Right here, we're expecting an integer, right? Actually, let me just go ahead and start over here. We're expecting an integer. We put the 7 in. Here, we're expecting a decimal. We put a decimal in. But we've already said that bad things happen if we do what's not expected in the program. If I put a decimal in here, we get this error, basically, that kicks us out. All right? So let's take what we've done here off, like this. And let's fix that. So the read actually happens right here. What we want to do is only do this read if we know that there's an integer waiting at the keyboard. Then we do the read, right? So the way you handle that typically is you put an if statement there. And the if is going to be as follows. Integer, it's going to be keyboard input. This is our scanner class that we have. There's another method called has next integer. Notice that the N is capitalized and the I is capitalized, but the H is not. Notice it's trying to tell me that it's Boolean, which means it returns true or false. So this is a method. If it returns true, then we do it. Make sure you understand what's happening. So we print the guy, it says enter an integer. Then it says if keyboard input, the method called has next int is called. If there is an integer there, then it's going to return true, and if that happens, then I do the keyboard input, assign the value to the variable. If this returns false, then nothing happens. So let me hit save and go ahead and do this guy. And you can see I have an error here, so let's go back and look and see what it's complaining about. We have a red underline here. When you hover over it, it says the local variable integer number may not have been initialized. Anytime you see something that hasn't been initialized, then just assign the variable a value of 0. We can delete this for the time being. Assign a value of 0 just because what's going on here is we are using the variable here, but it's inside of an if statement. This is a single line if statement. So Java doesn't really know if it's ever been initialized. So let's go ahead and initialize it for it. We'll go ahead and hit run here. Enter any integer. If we actually enter an integer properly, then this if statement will evaluate to true and we'll read it in. So it behaves exactly as we expect. However, if we now come down and hit 4.5, which is wrong, then the program just terminates. Basically, it doesn't terminate. What happens is this if does not evaluate correctly. right? It evaluates to false. So we never read anything from the keyboard. We already have a value of 0 stored in this variable, so then we just fall through. We bounce over this if effectively, and the program stops. So this if statement here, right before your scanner input, is very common. I suggest that you get in the habit of doing that. As we showed before, you don't really have to do it. If you're confident that you're typing in integers, then all you really need is this. If you're confident you're typing in decimal numbers and you're using next double, then you can of course use that. But if you want some sort of error trapping to prevent problems, then you really need to use this if statement here there. So I'm going to put a comment up here just to kind of show you the important methods here. The important methods here is inside of the scanner class is next integer. This one reads the next integer from the keyboard, right? The next one that we've talked about is next double. This reads the next floating point number from the keyboard, right? And then the next one that's very important is has next integer. This one returns true or false depending on if there's an integer there or not. We're just using that one here. There's also a complement for this one called has next double. And that checks to see if there's a decimal number there. So we can change this guy around to show you that right here. Let's just go ahead and change this guy. We'll change this to be a double. We'll change this guy to be a double, right? Just to change the names a little bit. Enter any decimal number. All right. If keyboard input dot has next double, that's what we're trying to do, double equals true, then double number is going to be equal to the keyboard input, but not next int. We need to be reading the next double. All right, and then we'll print it out. You entered the number, and then we need to, of course, use the variable that we have defined here, double number. Let's make sure this works. So we'll go ahead and hit this guy. If we put 4.5 in, then we get out what we expect to put in. So what we expected, because we typed in a number there, a decimal point there. So make sure you understand that there's a lot of stuff in this section that is kind of hitting you hard and heavy, and I understand that. And I wrestled for a long time with how to approach this. A lot of books don't even show you how to read anything from the keyboard until way later, because they try to teach you all about objects and classes and a lot of overhead just to be able to do something, in my opinion, pretty simple to read something from a keyboard. The bottom line is when you're reading from a keyboard, you need to remember these three things. The first thing is you need to import javautil.util.scanner. That's going to give us access to the scanner class, which has already been created for you. Then the first thing you want to do inside of your main method is create an object of type scanner. Right? This is just like creating something of type integer or something of type float. It's an analogy. It's not quite the same, but it's very similar. So we put the scanner keyboard in there. So that's telling Java, hey, we want to create something of type scanner. We want to name it this, and what we're going to do is associate with that a new scanner object. In this case, we're reading in from the keyboard, so this needs to be there as well. So now that we have this scanner object defined, and this is the name of the keyboard input, we can access all of the methods of the scanner class that's already been created for you. So in this case, the way you access those methods is you put the name of what you've created, dot. The dot says, hey, I'm going to access a method that of the type that I have in this class. In this case, has next double is going to be a method that just looks at the keyboard and says, is there a double there or not? If there is, then true. Return true. If not, return false. So we're checking to see if there's a double at the keyboard. If it's true, then we'll read that keyboard input with the method called next double, and we'll assign that to this variable that we've created. So this is really all you need. I mean, you could eliminate this if you really wanted to. As you saw in the beginning, all you really need is this to read the keyboard input, and then you can do whatever you want with it. This is just trying to catch error. So in most of my examples, you'll probably see that I have this there. Just keep in mind that this is doing the real reading end of what we have. Once we have this keyboard input read as a double into a double variable, we can do anything we want. Here we're printing it to the screen. We can multiply, divide it. We can do whatever we want. We can put it in if statements and so on there. So make sure you understand this, and then go off into the examples or I should say the exercises, and try to do them yourself. because you really need a little bit of practice with learning how to use the scanner class. It's not hard to do. Really, you just have to put this line in. You need to create your scanner object there, and then after that you just use it to read the keyboard input, and you can really create rich Java programs to really enhance your learning when you can create a program that reads from the keyboard and then do things with that input. You're going to learn a lot more than if you're just writing these static programs that are just declaring variables over and over and over again. So make sure you understand this, do the exercises, make sure you understand how the exercises behave, and then follow me on to the next lesson where we will continue learning Java.